Okay, everybody, let's go ahead and get started again. So we are back with our next speaker, Vanji. He is on the project management committee member and a committee of the Apache Synapse Project. So he's going to come and talk to us all about Ballerina, which I'm super interested in because I don't know that much about it. So without further ado, let's go ahead and introduce Vanji. Welcome.
Thank you. Thank you. Thank you for introducing me.
Okay, so let me go ahead and I'm going to stop sharing. I'm going to change you. And then can you share your content?
Sure. I'm sharing my first screen over here. All good?
Yep, give me 1 second. Oh, I have to switch this. There we go.
Cool,
okay.
Thanks.
Yeah, all right, thanks. Go ahead.
So Ballerina. So I mean, everybody wonder what's that name belongs to and how this related to programming. But over the time when I start to talk about this programming language, you will understand. So let's dance together on this Ballerina concept. So Ballerina is a open source cloud native programming language that designed for solving most of the network related programming challenges that we have all the time as programmers. So I'm Vanji Swajoti, and everyone know me as a Vanji, and I'm a part of the company called WSO2. It's also another open source company who's focusing on integrations. So I've been involved with solving integration problems and in the enterprise context for more than a decade. So with that experience, when I start to look into different programming languages, how that can be solve our day-to-day integration problems. So one of the interesting projects that I came across was Ballerina, and I started to adapt that moving forward. So a quick note, when we look back in 70s, we start with the mainframe, right? So the most of the applications are like monolithic business application. And over the time when the internet and mobile start, we start to see different set of disaggregated applications start to appear. For example, we start to see enterprise apps and then departmental apps to solve the particular business unit problems. And then we start to see software as a service apps. And now we see public and private APIs. And but the current era that where are we right now is pretty much most of the things are serverless and microservices. So this leads increased demand in causing disaggregation. So having said that, looking into the big picture, so when the apps and APIs are started to disaggregate, this leads more endpoints. And the endpoints growth is pretty much exponential. As you can see, the endpoints can be anything that from function to API, even a data point, even it could be a SaaS app like a Salesforce, or the legacy apps like any, the banking apps or the ERP systems, or even it could be IoT devices or devices, right? So if there is something that can be identified, and if we have seen these disaggregated components become a network accessible, we call them as endpoints. So whether it is a data app, API, microservice, or serverless function, everything is becoming a programmable endpoint. The number of endpoints, as I mentioned, it's exploding over the time. So this brings lots of different challenges and problems into the cloud native apps. So when we have like n number of endpoints, the integration is increasingly disaggregated world. So the app we will write increasingly depend on these endpoints, right? So increasing integration in this discipline of resilient communication between endpoints become a very challenging aspect. So it's not easy as we think, because there can be challenges to include compensation, even transaction, different events, circuit breakers. If there is many different protocols that we have to handle, for example, HTTP to WebSocket or HTTP to JMS. So there are lots of different protocol handling involved. And more than that, the complexity of the mediation and orchestration between these endpoints. So all of these are hard problems, to be honest. So the Ballerina, the cloud programming language, trying to solve this by providing a first-class understanding about these network components and try to give a great language tool set for a programmer so that they can solve this easily. So that's a bigger picture why the Ballerina started and how it started to evolve. So when we start to think about language, I mean, um, it's not only give a great variety of a tool set to solve the network problem, but also it gives a full set of libraries that is available in any other generic language out of the box. So these are like few components that I have took a screenshot, but if you go to ballerina.io, you will see the full set of information that you can try out. So it's starting from the basic language concepts to all the hard problem that we were talking previously, how to work with the network over the network, and everything. As you can see over here, the JSON, XML, everything are like first class citizen within the language itself. So the program language completely understand the JSON, XML, or any other protocols and data format that you would think of, which include the gRPC and WebSockets and everything. So without taking too much of time into the talking about the each and every feature set, I mean, I like to walk you through with the code so that we can learn and dance together. So as a very first step that I already have download the Ballerina language, and I have installed. It's available in all different platforms, and I have already downloaded. At the same time, I have also installed the what do you call the plugin for my IDE, which is my IDE is I'm using Visual Studio. Okay, so let me bring my terminal to this side. Okay. So very first exercise that we are going to do, as any other programming language, to say hello to Northern VA code camp. So what I'm going to do is simply going to create a file. Let's say here we are. Can be. So, okay, so I'm going to create a very simple file over here. Let's say hello REST API. .bal. So the Ballerina recognized using the BAL extension. So I have opened that, and right. So first, as any other language, right? As a very first step, I'm going to import a few libraries. So import Ballerina. I want to have HTTP library because I'm going to write a service, REST service over here. So to do that, what I will do, I will type service. So service, and I'm going to expose the HTTP service. So when I choose the HTTP service, it will give me a very simple structure where I can start to code on. So over here, the service name, which is well known as a context, right? What I'm going to say is hello, and this particular service is going to up and run on port 8080. So let me change to different port, 9090, something like that. And when the requests come in into this particular service, it will go to it will reach out port 9090 and look for the context called hello. And within hello, there is a resource. So which means the way that I can say is it pretty much look like something like this: HTTP localhost. That's my host 9090/hello, and within hello, I'm defining a resource which is say, let's say hello. Yeah, let's say hello. So when I invoke this, I want to receive a message back. So by default, this resource is going to be a get method in HTTP. So let's write something into that hello message, right? So as you see, the caller is nothing but a client that making a request. At the same time, the request is the representation of HTTP request that we are receiving from the client. So what I'm going to do as a very first step, well, results, I'm defining very simple variable over here, and the caller. And since it's a network language, it has a notation like, okay, write into caller's language, something like this, dash. And I want to write to that caller the respond. I'm going to respond something over here. Say hello. Northern VA code camp. And closing. So what I'm trying to do over here, simply say, when I receive a request, write a message back into that request saying, hello, Northern VA code camp. And let's handle some errors, because the programming language itself designed for solving the network problem, most of the network problems, right? So we know that in network, the errors and glitches are very common. So the language also understand from the core that how to deal with this. So what I'm going to do, if result is error, oops, I had to remove this. Yeah, error. And then what I'm going to do, simply going to log. So when I try to give the log, as you already say, notice the language itself import the Ballerina log library inside there. So I'm going to type print error, say error sending on. And then what I'm going to say is suppress that error within. Yeah. So what I'm doing here is I'm suppressing the error within that log. So this is a very simple service that I written, right? So what I'm going to do, I'm going to invoke this. Let's say, let me copy this and try to invoke, because this is a get method. So my expectation is this should up and run. It won't run because I didn't deploy this service. So what I'm going to do, so very simple command, Ballerina run hello REST API pal. So there is an error compiling. Yep. No entry point found. Yes, that's true. The reason for that, I haven't enabled this. And save this. Area 51. Concurrency. Ballerina run. Hello API. So as you can see, the service is up and running on port 9090. So let me do that over here again.
Oh, so Vanji, real quick, someone's asked if you could just zoom in on your code. So
yeah, sure. Yeah,
show it
sure.
a little larger. Thanks.
Sure. What about now?
Yeah, I think that's better.
Okay, cool. So what I have done right now, as you see, I have important a few libraries that I'm interested in. So clearly, as you see, the HTTP is one of the library that I have important. And on top of that, I have written a very simple service that's going to say, hello, Northern VA code cam. So when I invoke that service, it's right away providing me the response back that I was trying to compose within the code. Cool thing, the magic thing that I'm going to show you over here. So whatever I'm writing in my code will be represented as the sequence diagram. So most of the network programmers and integration developers who mainly focus on these diagrams and everything to depict their architecture. So as you see over here, the representation of the code right away showed as the sequence diagram as well. So right now it's very simple, but when we start to write the code more complex enough, you will see the bigger picture and how the code is interacting with network component in the code. So let me zoom in this. So another cool feature over here, as you see, so the if condition, right? So that is also even represented in the sequence diagram. So let's get a little further on this. Let's focus on how this will work with the what do you call for the complex constructs. I'm going to move to next. So we just talked about how we can expose the simple REST service using Ballerina. So now the programming language got its own annotations, which allow you to customize your code and expose much more feature-rich values. So what I'm going to do for that, right? Now I haven't done any detailed information. This is out of the box feature it's coming on. So what I'm going to do now, I'm going to say, configure this service furthermore. For example, the service level configuration. So for example, if you want to attach this into a different paths, so let's say you have different path that you want to attach. We call this as a base path. So the base path is the core root, and then attaching the the service into the the service resource into the much more complex thing. For example, let me add one more resource over here so that you can understand what I'm going to try to do. So resource function, the name is going to be, let's say, hi, and of course it's a endpoint is the caller, and it's a HTTP request is coming in. Oh, I can say this too. HTTP caller. Right. So what I'm going to do over here, I'm going to attach resource configuration. For example, HTTP. Resource config. And then within the resource config, I'm going to define my path, which is again the root path. And then finally, I'm going to say what are the methods that it's going to support. So for now, what I will do, I will say post. Right. So in very simple terms, what happening over here is for each and every resources, if you want to have very fine-tune or configured manner of exposing these services, now you can have an option to define those within the programming language itself. So quickly moving to the next concept over here, right? So connectors. So in the networking program, there are many endpoints. I mean, if you start to identify each and every endpoint and start to implement everything by yourself, it'll take lots of time, and it's not easy as we think. So for that, the Ballerina providing another cool set of feature. They call it as a central ballerina.io. So that's a collection of reusable code, and to solve the connector problem. For example, if you want to connect with SFDC or the Salesforce, or if you want to connect with the SAP, or if you want to connect with the any SaaS offerings or any other API, and if the contract is well known, you can create a module and attach into the central Ballerina and reuse that within your code. Or otherwise, you also can put it into the marketplace and let others also can utilize your connectors. So the connectors, the way that work, so in this example, right? So let's say there is a function, or there is an API exposed through the Amazon Recon. So you want to invoke that. It's simply the service developer can utilize that code or the Ballerina central repository and obtain that connector, and then from there it can be reutilized very simply. To do that, there is simply what we can do is import the connector. right away saying like import WSO2 Twitter or any other naming convention that it has been given over there. So for example, what I will do, I will showcase you that feature too. And give me a second. Okay, yeah. So when you do that, what will happen over here is the whole construct that given by the connector will be available for the rec service, and then from there you can create the complete integration flow within the rec service and expose it to your clients. For example, over here, if I take a Twitter, so the Twitter configuration itself available as a configurable manner, and you can configure the Twitter client. And then the Twitter client becoming a very simple code representation for the endpoint that we are trying to invoke. So as I mentioned already in my previous code, this particular notation simply representing how this can be invoked through the network and what we are trying to do. So we already have defined a Twitter client, and the Twitter client is already configured. So which means when in the code, if you say Twitter client and invoke the tweet method with the parameter that you pass, simply it's making a network call. And then, as I already mentioned, you also can handle all the errors within that. So that make the programming language completely understand the resiliency and the networking concepts over there. So let me move to the next level, which is the concurrency. So in the Ballerina, the concurrency is a part of the core implementation and concept. So to do that, let's take a quick example over here. Let me create a new file. Let's say code conf. So if I open my the sequence representation over here, there is a concept called worker. So worker allow you to execute the program or execute the piece of code in parallelly to the other workers. So for example, over here, we do have two workers that running with two different what do you call, two different computations. And then if you want to integrate that into one single outcome, again, the Ballerina code allow you to do that by doing it through its own constructs. That's how the Ballerina handle the workers. So I mean, this will be very useful when we start to do the asynchronous way of handling the calling the different endpoints and everything. So let me move to the next level, which is how we handle the features, and especially over here. Let's take a very simple example. Where if you want to do a recursive calls, and in a let's say you want to execute a Fibonacci series, at the same time, if you want to make the external call, you can simply utilize a feature called future. And also the Ballerina provide out-of-the-box support for the asynchronous input-output. For example, so this particular code that I'm trying to show you here is I do have a client that I want to invoke the endpoint, And when there is when we make a get call to this particular endpoint, and when there is when this endpoint is asynchronous and not responding back, still you can the code itself understand the transparent non-blocking input-output usage and promote the optimal resource usage and handle the large number of active connection between the endpoints. So one more cool feature that I have seen in this language is the Docker and Kubernetes support natively. For example, if you want to build the Docker image and Kubernetes image out of the box, the language provides the constructs for you. For example, let me go to learn by Ballerina by example. Over here. So let's say you want to compose a Docker image for this particular code. Or let me take the service code that make much more easier. So I want to create a Docker image for this particular code. So what I'm going to do, simply going to say Docker config and provide the basic metadata for this Docker config. So let me do that. Docker config, and what I'm going to say, the name that I'm going to give, hello world, and then the tag that I'm going to give is 1.1. So that's the basic thing. So when I build this, so when I build the Ballerina, so what's going to happen is it's going to build the Docker image as well. So let me do that. I'm not running it, but I'm building it. So as you see, so it has created the executables so that now it's available as the images as well. So that if you have connected this with the what do you call your endpoints and the Docker registry, which is this. I haven't done that yet. So what I'm going to do, I'm going to build this again with the listener. So, and I don't need to provide this anymore as either. I have already done it, but it's okay. We can keep that as it is. And I'm rebuilding this again. So now you can utilize this Docker image right away through your Docker repository and start to access the service from Docker ecosystem itself. Likewise, there is a complete feature set that allow to do that in other ecosystems as well, like Kubernetes, or if you want to run this in OpenShift, or Knative, or Azure Functions. The programming language is providing you a construct to deploy this into the cloud native ecosystem right now. The next feature that I like to highlight over here is the support for the AWS Lambda. So AWS Lambda support, let me take this again back. Yep. So when you create a Ballerina functions or Ballerina service over here, I mean, it's available as the the REST service out of the box. But if you want to expose the Ballerina code into Lambda, Amazon AWS Lambda, I mean, for that you have to put some annotation along with the AWS Lambda's functional annotation, and so that the what do you call, the Ballerina code itself understand you are trying to write Lambda functions there. And once you construct these samples and the code that you want to expose, you can simply utilize the AWS CLI tool. And from there, you can, when you invoke the Ballerina build function, the Ballerina will automatically take all the configuration that you have done. At the same time, it will take your code and put it into your AWS Lambda function in your ecosystem. Likewise, the Azure functions also happen the same time. Obviously, you also always can take the define everything in what do you call Azure function itself or AWS Lambda itself, but sorry about that. So sorry about that. So you can write the code into the AWS functions itself or Azure functions itself, but this provide one single set of implementation along with the necessary tool set that you can utilize to create the network interactions that we already saw in previous discussion. And then when we start to consider observability, the Ballerina provide first-hand support for the latest tracing capability, including the open tracing and open telemetry and everything. So, for example, if I take the observability over here, the distributed tracing and the metrics are like part of the language itself. So let's check out this how the distributed tracing works. So the Ballerina implemented on top of the open tracing concept. So we use spans and everything. So in your code, if you want to have a proper tracing and in a distributed manner, it's always possible to do that using the constructs that provided by Ballerina through observe constructs. At the same time, when we looked into taking metrics by usage, again, the observe library providing a wide variety of feature set to do all of these within the code itself. So likewise, the gauge-based metrics also available out of the box for you. So once we implemented all of these within our code, I mean, simply you can plug in with any APMs or application performance managers or any tracing tools like Jago or Zipkin, and you can start to observe how the particular service up and running and how's the interaction and everything. And this will be completely available as a distributed manner, and the language itself understanding the whole concept. So it will show off right away. So this is Prometheus and Grafana support, because I mean there is no defined support for these vendors or the products, but this is available as the open tracing implementation, so that you can easily plug in with these products and take the metrics out of these services. And finally, there is a need of implementing an open API, because whenever we implement a service, end of the day, we want to expose this service for our internal users or external consumers, so that without a proper contract between these users, it's pointless. So the language itself support the open API specification out of the box. So which means you can bring in the open API specification and create the Ballerina code right away, or write the Ballerina code and generate the open specification, open API specification thing. So for that, let me quickly show you example there. So right now, we are going to try out the Ballerina to Open API. So to do that, we don't need to do anything much. We don't need to change any code changes. It's just a matter of calling the construct that we want to trigger. So for that, the code command over here is Ballerina Open API, and from there generate contract. So we can provide the modules and service that we are interested in, and then they provide the contract files or you are intended to create, or and if there is any binds that you want to skip, you also can skip those. The other way around, I mean, Open API to Ballerina is also facilitated by the Ballerina language itself. So for that, we can simply call Ballerina Open API and generate services, and from there we provide the Open API contract. So from there we can generate the code, Ballerina code. And then we can fill up the the blanks that we have to fill up to implement our functionalities. So the way it works is, I mean, with our IDE, which is right now I'm using VS Code, but at the same time, this also available. The IDE support also available with the IntelliJ as well. So when we write our code or write our execute our code to create the new Ballerina code, so it'll basically generate the bal source file, which we written by hand right now. So once we wrote that code, we can always utilize the build, which we already tried with the Docker and previously. So when we try out the build thing, basically what we are doing is doing the version controlling over there. So over the time, what you also can do is, since the deployment and everything are available out of the box, which means we can do a CI/CD process without any of other new effort. And then once you implement all of these, either you can use everything by yourself, or if you want to push this module into the Ballerina Central, it's also possible to do that by putting into a Ballerina Central registry. So to learn about these programming languages, I mean, what you can do is very simply go to ballerina.io and learn by examples. But at the same time, I also want to point out that now the Ballerina team has released the version 1.2, but at the same time, they're also working upcoming release called Swan Lake, which is about to release early next year. So the very important change that I would say here is that there are lots of new construct coming up within the Swan Lake release. So with that, I will quickly answer the question if there is anything.
Hey, Vanji, thank you so much for this presentation. It was really, really cool. I don't think we've had any questions. Seems like we've got some really good engagement. There's some interesting comments I saw on Discord. So I think this was really cool. I've not heard of Ballerina before, but definitely something that as I kind of get more into building more cloud native applications, and I feel like it's something that will be really useful for me. So thank you so much for your time. I think we're gonna go ahead and just end this session. We'll head over for lunch, everyone who's on. And yeah, there might be a few more questions on Discord on the cloud channel. So thank you so much for your time.
Sure, thank you.
All right, bye.
Bye-bye.